Okay guys, this video is going to be about 9.3, which is going to be about special parallelograms. Basically, shapes are parallelograms, but they have its own unique features. So let's go ahead and just do a quick review of what a parallelogram is based on our previous lesson. So looking at this parallelogram here, let me label everything that we know about parallelogram. We know in parallelogram that we have two pairs of parallel sides. We know that opposite sides are the same length. We know that opposite angles are the same length. Same measurement. Oops. We know that my diagonals here, which are these lines, they bisect each other, which means this and this have the same distance, and this have the same exact distance. We also know that in my parallelogram, angles are consecutive or 180, which means this angle and this angle, they add up to 180. This angle and this angle, they add up to 180. This angle and this angle adds up to 180. And these two angles right here, they add up to 180 degrees. Now, the shape that we're going to learn about today carries all of the properties, all the features of a regular parallelogram. So all of these that we just talked about still applies, except it has, a few new things that's unique. Okay, now let's first learn about a shape called the rectangle. Now the rectangle, just like everything else we know about parallelogram, but it also has something special about it, which is that it has 4 right angles. So let me go ahead and label it. It has 4 right angles. Okay. Something also in rectangle that we don't have in regular parallelograms is that they have diagonals that are the same length. Okay. So it means right here, if you look at it, these two diagonals have actually the same length. Okay. Now, if we look at the regular parallelogram, we notice that, well, we have these two that are the same, right? But now, if we have both diagonals the same, it turns out that now all of these segments will have the exact same length. Okay. Now, once you label these are the same length, you'll realize here, after you draw your diagonals, in your triangle, you can actually see 4 isosceles triangles. You can see that this triangle right here, they're isosceles triangle because I have a side here that's congruent. Just a reminder, your isosceles triangle is triangles with 2 of the congruent sides. And when this happens, your angles here are also the same. Okay, so please remember in rectangle, you have 4 isosceles triangles because we have an angle here, 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 and here. And this also means if you're given an angle right here, then you know, because this is isosceles triangle, then you know that this will be the same angle measurement. Okay, now let's go ahead to the next shape. Now, another shape that we have to learn about could be called a rhombus. Now, a rhombus, something special about it is that it has 4 congruent sides. 4 congruent sides. Now, when they have 4 congruent sides here, we're going to label it all the same, like this. Now, just a term that you have to know, when it says all 4 congruent sides, when this happens, we call this equilateral. And just a reminder, on the last one, I forgot to mention, just like how on a rectangle, we have 4 right angles, when we have all angles the same, we call this equilateral. Equiangular. Okay, so back to my rhombus. I know my rhombus is equilateral because it has all 4 sides the same. Now, another thing about rhombus is that their diagonals are actually perpendicular, meaning that they create 90 degrees angle. This is 90 degree, this is 90 degree, this is 90 degree, and this is going to be 90 degrees. Also in diagonals here, my diagonals are angle bisector. A reminder of what angle bisector is right here on the little picture right here. Okay, if I have angle right here, my angle bisector splits this angle into equal parts. So if I have my diagonals as angle bisectors, let me use a different color right here. If this is my angle bisector, then this means this angle right here and this angle right here are the exact same measurements. This also means from previously, parallelograms, opposite angles are the same. This also means that if these two are the same, then these two are also the same. Well, these two are the same because of the angle bisector, but if I were just giving like one of these angle measurements, I will know what's the angle measurement for this one, and this one, because I know opposite angles are the same. And same with my other pair right here. This have the same angle measurement as this. And since opposite angles are exactly the same, it will be the same over here on the other side. And that's all we have to know about a rhombus. Now let's move on to a square. Now a square is like a combination of square and square is a combination of rectangle and rhombus. View square as a baby of rhombus and rectangle. It has all the properties that's unique to rhombus and rectangle. It has all of them. So a square has, same as rectangle, has 4 right angles. That property we get it from the rectangle. It has diagonals. They are the same in length. These we get for the rectangle, but it also carries properties of rhombus, which is that they have 4 sides that are the same. They have diagonals that are perpendicular, meaning all of these will be 90 degrees. They have diagonals as angle bisectors, meaning each of these little angles right here will be the same angle measurements. So this angle and this angle have the same angle measurement, and so does this one, this one. Now, since in a square, all your angles is 90 degrees, which means half of 90 will be 45. So each of these angles is actually all just going to be 45 degrees. And 45. Okay. Now, with these in mind, let's, just take these information and let's do a couple of questions together. Now, looking at example 2 right here, example 2, question 1. Now, we're told that this is a rhombus. Now, just by looking at it and knowing the fact that it's a rhombus, I know that angle 1 and angle 2 will be exactly the same length. Because if you look at it, right here, I say that rhombus, when you have an angle bisector, when you have a diagonal, it acts as an angle bisector and splits this angle into half. Okay, so we know that angle 1 and angle 2 must be the exact same length. So let me just go ahead and label both as x here, since I know that they are equal. Now, in order to find my x here, or my angle 1 and 2, I know that this angle right here and this angle right here, they are consecutive angles, because rhombus is still a parallelogram. So I know that these two are consecutive angles, meaning they are supplementary and they add to 180. So I know 124 plus 1 and 2 together, which I know x and x will become 2x, will equals to 180. Then all I have to do is just solve for x. That will give me my angle value for angle 1 and angle 2. So let me go ahead and subtract 124 from both sides. This cancels out, gives me 2x on the left. On the other side, I have 56. I divide both sides by 2, and this gives me x equals 28. Now let me do the next one. Okay. Now looking at part B, just looking at it, my angle measurement of angle 1 here will be 90 degrees, because I know in rhombus here that all my angles that's created by my diagonals are going to be 90 degrees. So angle 1 will be 90 degrees. So let me go ahead and label everything I know. 90, 90, 90, and 90. Now, just looking at the picture, I also know that my angle 2 and angle 3 will have to be 50 degrees. And the reason is because, like I said previously, that my diagonals are angle bisectors, right? My diagonals are angle bisectors. So if this is 50 right here, this is 50 right here. But I also know from the parallelogram, which my rhombus is a parallelogram, the opposite angles are equal. So this means this is 50 here, and this is also 50 here. Lastly, to find my angle 4, well, I know angle 4 is inside a triangle right here. Right here. This is inside this triangle, angle 4. Oops. Angle 4 is inside this triangle. I know inside my triangle, the total degree must be 180. So to find my angle 4's degree, I'll just do 180 minus my 90 that I have, minus the 50 that I have, and that, whatever is left, will be my angle 4's measurement, which in this question right here, my angle 4 will be exactly 40 degrees. Moving on, let's go ahead and do question C. Now, just looking at the picture, but I know it's a rhombus, I know one thing for sure, which is that my angle 2 must be 90 degrees, because I know in rhombus, my diagonals are perpendicular. So angle 2 here will be 90 degrees. I also know, just by looking at it, I know that if this is 78, then the other one must be 78, because my diagonals acts as a perpendicular bisector. So my angle 1 will be 78 degrees as well. I also know, just by looking at it too, that if angle 1, if these angles are all 48 degrees, then these two angles must also be 48 degrees because opposite angles are the same. So let me label angle 4 as 48 degrees as well. Okay. Now guys, by the way, another method that you can tell that angle 1 and angle 4 are going to be, the same measurement from our previous knowledge is that we know all angles, all sides are equal, right? So if you look at it on the right here, this and this actually creates an isosceles angle, which means that their base angles are the same. So if this was 78 right here, this must be 78 right here as well. Just if you want to do another method. Now let's go ahead and try to find angle 3. Let me label all these back. Now, to find angle 3, I know angle 3 is inside a triangle right here. I know inside triangle, everything must add up to 180. So to find my angle 3 here, I'll just do 180 minus 78 minus 90. And this, whatever is left over, will be my angle 3, which my angle 3 in this case right here will be 12. Let's go and try to find question D. Now question D here, we still have a rhombus and we're trying to find the side of MA. But I'm giving nothing for MA. Well, I'm giving nothing, so how am I supposed to find it? The way I can find it is that I know rhombus have all sides that are the same. Meaning, as long as I can know either one of these measurements, then I can know the measurement of MA. So what I can do here is that I'm going to first find my X, then plug it into any of these. That will give me a measurement of one of these sides, and that will be my side measurement for MA. So here's the question. How do I find my X? Well, if you look at it, you know all of your sides are the same, right? So you can set up 2x minus 1 is actually equals to 10x minus 17, because in rhombus, all sides are the same. So then I will subtract 2x from both sides. This cancels, gives me negative 1. On the other side, gives me 8x minus 17. Then I'll add 17 on both sides. Cancels, gives me 16. And this gives me 8x on the right side. And my x here will be, let me divide it by 8 just so you know what I'm doing. And my x here will be 2. Now, I'll just take this 2 and plug in any one of these. Okay? It doesn't matter which one you plug in because they're all the same length. So obviously, I'll just pick the easier equation. So let me do 2 times 2 minus 1. Well, that gives me 3. Meaning, AT is 3, but that also means my MT here is also 3. Moving on to the next one. It says A, B, C, and D is a rectangle. Now, let's draw out my rectangle first. On these ones, if you're given information and you have to label it, you don't have a picture, then you have to draw a picture out. So here's my rectangle. It's going to be A, B, C, and D. It says that AC was AX plus 2. Notice it's A to C, so it's a diagonal length. It's AX plus 2. And we have BD here is 5x plus 11. We're asked to find my length of AC. Well, I know my AC was AX plus 2. They already told me right here. But I need to figure out the x value. So how can I find my x? Well, I know in a rectangle, my diagonals are equal. So I can just set up AX plus 2 equals to 5x plus 11. I'll just solve for my x and I'll plug it into my AC to find my AC value. So let me go ahead and subtract 5x from both sides first. Gives me 3x plus 2 equals, this cancels, gives me 11. I'll subtract 2 on both sides. This cancels, gives me 3x. On the other side, this gives me 9. Then I'll divide both sides by 3, and my x here will equals to 3. Then, to find my AC value, I'll just take my AC equation, which is 8x plus 2. I'll plug it in. I'll do 8 times 3 plus 2 this will give me 26. And this means my AC right here that I'm trying to find is going to be 26. Okay. Next question, same with rectangle here, okay? Now it's telling me that my angles EGF, which is this angle right here, is 5y minus 46. I'm being told that my angles D, F, and G was 3y plus 25. It's asking me to find the value of y. Now, knowing that this is a rectangle, how can I use this knowledge to find my y value? Well, I know in a rectangle, all my diagonal segments right here are equal. And once I label this, I realize, wait a second, this right here is actually an isosceles triangle, meaning their base angles right here are the same. So to find my y, I'll just do 5y minus 46 equals to 3y plus 25. I'll subtract 3y from both sides. This cancels, gives me 2y minus 46 equals 25. Then I'll add 46 on both sides. It'll give me 2y equals 71. I'll divide 2 on both sides, and my y here will equal 35.5. Okay, last question to go, and then we are going to be done. Now let's take a look at this one, okay? So we have EGF is equaling to, right here, is equaling to 3y minus 46. Oops, not 3y minus 46. 5y minus 46. We know that my angles right here, DFE, is going to be 3y plus 25. They're asking us to find the value of y. Now, different from the other one, this time we're not giving this angle and this angle. We're giving this angle and this angle right here. Now, how can we find our y? We know now these two angles are definitely not equal to each other. But what we can do here is that, well, we know that this here is 3y minus 46. That I know that this is the same right here, right? And we also know a rectangle has 90-degree angles. So let me go ahead and draw my 90-degree angles right here. This means this side and this side adding together must be 90 degrees. So we can set up equation, which is 3y minus 46. I'm not 3y, guys. I keep on saying 3y. 5y minus 46 plus 3y plus 25 will equals to 90. Then I combine my like terms. This 2 becomes 8y. These 2 right here becomes minus 21 equals 90. I then add 21 on both sides. This cancels, gives me 8y. On the other one, this gives me 111. I divide both sides by 8 here, and my y here will be 13.875, and that is all of 8.3. Okay, please go ahead and try each of the questions on your own if you need more practice, and please do your homework.